So today we are looking at voltage in parallel circuits. If you have already seen the video on voltage in series, then please skip to this part of the video. So we need our definition. Voltage is equal to energy per unit charge. And we need all of the stuff from our previous analogies. My cells are the post offices, the components are the houses, the coulombs are the postmen, and the packages are the energy. Now, here's the key for my analogy to work. Each individual postman must deliver all of their packages before returning to the post office. Here is a series circuit. The supply voltage is 6 volts, which means that this bulb here receives 6 volts. Okay, let's add another branch to our circuit. How much does each bulb get now? In order to answer that, let's consider our postmen. So we're going to think about 2 postmen coming out the post office and arriving at this junction here. Remember, both of the postmen both have 6 packages each to deliver. Now, from our previous videos on current, we should know that at this junction, the postmen split. One postman goes along the top branch and one postman goes along the bottom branch. So let's follow our postman on the top branch. On his journey back to the cell, he is only going to go past this house here. So he needs to drop all of his packages over that house. So that house, which is representing my bulb, receives 6 volts. Okay, let's have a little look at the second postman. He went down the other bottom branch. And on his journey back to the cell, he only goes through this house here. So he needs to drop all of his packages at that house. That house receives 6 packages, or my bulb has 6 volts over it. So here's my golden rule. In parallel, the voltage from the supply gets applied across each branch. Okay, brilliant, thanks. Well, that was easy. Not so fast. What if you have a circuit like this? Panic? No need. Let's think about our postman. Okay, let's follow the first one. He goes through the top branch, and on his route back to the cell, he only goes past this one house. So all of his packages get delivered there. The supply is 6 volts, then there are 6 volts over this bulb. That one was exactly the same as our previous example. Okay, but let's think about the second postman. Now he received 6 packages from the post office, but he's going down this second branch here. Now along this second road, there are 2 houses that my postman will go past before he reaches back the post office. The postman could give this house 3 packages and this house 3 packages. Or he could give this one 4 and this one 2, or 1 and 5. It's like the postman is in a mini series circuit. He will split his packages between the 2 houses, and the total number of packages received by both of the houses together will equal 6. Let's say these 2 houses are identical, so the postman delivers 3 packages to the first house and 3 packages to the second house. 3 volts over the first bulb and 3 volts over the second bulb. Okay, let's have a look at an example. What is the voltage over this bulb? Well, this is a parallel circuit, so the voltage from the supply is applied across each branch. And since there is only one thing in each of these branches, if the supply is 3 volts, then the voltage over this bulb must also be 3 volts. Okay, and what about this circuit here? In this circuit, again, it's a parallel circuit, so the voltage from the supply gets applied across each branch. So in the first branch, there's only one bulb, so if the supply is 3 volts, then the voltage over that bulb will also be 3 volts. But in the second branch, the whole branch receives 3 volts altogether. This bulb here has already received 1 of those 3 volts. So there are a total of 2 volts left for this bulb here. Okay, hope you found that helpful. Please do download the notes and click on the next video to have a look at some calculations